So let's continue our discussion and look at the composition of two functions. So you can think of the composition of two functions as starting at one point, plugging it into a function, and then plugging it into another function, like an assembly line. So imagine we have an input here, x. We give it to the function g, who outputs g of x. Then it takes that, hands it off to f. F plugs it in and gives you f of g of x. So f of g of x means first you plug into x, into g, and then you plug that output into f. And we call that entire process f of g. Again, f of g of x just means first you plug into g of x, and then you take that output and plug it into f. So let's see if we can't do an example. It says find f of g of x and g of f of x for these two functions. So again, it's an assembly line. Let's first find f of g of x. That means you take g of x, whatever you get. So I plug it into g of x. I plug x into g of x, and I get out x minus 3. And then you plug that output into f. So I take f of that answer. So I take f of that answer. And what does f do to things? Well, it takes whatever you get it and squares it. That's what f does. So it takes what we give it, x minus 3, and it squares it, squared. So that would be your function f of g of x. It's this. If I wanted to do g of f of x, it starts off by first plugging x into f, and then taking that answer and plugging it into g. So f of x, when you first give something to f of x, in this case, it gives you x squared out. That's what x squared is. And then you plug that answer into g. What does g do to things? It takes what you give it, and it subtracts 3. So it takes what you give it. So I'm going to do g of this input. It's going to be g, which it's going to take that input and subtract 3. So that's going to be your answer. So if you first do f and then apply g, you get this. If you first do g and then apply f, you get this. So it's going down the assembly line in two different directions. So that's part A. For part B, f of g of x of 5 would simply mean I take this function f of g, which is crap minus 3 squared, and everywhere where there's an x, plug in a 5. So it's going to be 5 minus 3 is 2 squared, or 4. If I have g of f of 5, it means I take my function g of f, which is crap squared minus 3, crap squared minus 3, and I plug in 5. So it's going to be 25 minus 3, which is 22. Cool. So again, this is just another way to create a function out of f and g, is make an assembly line. First you plug into one function, get an output, and then now that becomes the input for the next function. It becomes the input for the next function. Input gives you this output, and that output becomes the input for the next part of the assembly line. Okay, so let's see if we can't find the composition of functions. So here I've got two functions. I've got f is square root of x, and g is square root of x, square root of 2 minus x. So it says find that and their domains. So let's look. So first, if I do f of g of x, that's going to be, remember, you work from the inside out. So first I plug into g, get an answer, and then I plug that into f. So if I plug into g first, I get this. And then I turn around and take that output and plug it into f. Well, what does f do to things? It takes the square root of it. So that's simply going to be the square root of what I give it, the square root of 2 minus x. Weird. right? That's a weird little function. So what do we worry about this with this function? The stuff underneath this radical right here has to be, the stuff under the radical right there, that has to be greater than or equal to 0. So in other words, x has to be greater than, less than or equal to 2. So on our number line, it's either 2 or less than. So it goes from negative infinity all the way up to 2. Let's look at the next function. So that's pretty cool. If you take our two functions, that's what f of g looks like, right? It goes from 2 all the way out to negative infinity is the domain. We can see that here on this graph of f of g. Pretty cool. So now let's find g of f of x. Again, first it's going to plug into f, and it's going to take that output and give it to the function g. So what does f do first? It takes the square root of something, and then you hand off to g, and what does that do? It does the square root of 2 minus whatever you give it. So it's going to be the square root of 2 minus whatever you give it. In this case, you give it the square root of x, right? So in this case, what do we need to happen? Well, let's see. First off, I know that I need the square root of x. This output is always going to be positive, right? And so that's why we only have output values that are greater than 0. But if we're thinking about domain, I need 2 minus the square root of x. I need that to be greater than or equal to 0. That means I need to know where the square root of the square root of x is less than or equal to 2. Those are the only inputs you're allowed to put in. Well, where is the square root of x less than or equal to 2? That means that that would mean if you square both sides, we would get that x has to be less than or equal to 4, right? So that's why x has to be less than or equal to 4, and you see that here on the domain. You're only allowed to plug in things between 0 and here, but why do we know that those x's are always positive? Well, because inside of here, this, what you plug in, inside of that radicand also has to be greater than or equal to 0. Since this is the only thing in the radicand, that means that x has got to be greater than or equal to 0. Cool. So that's why all of our x's have to be greater than or equal to 0, but they also have to be, so there's 0, they also have to be less than or equal to 4, and so the intersection of those two is between 0 and 4. And that's what you see over here in the picture. Okay? So on a high-stakes exam, I don't think I'm going to ask you to find the domain of these things for the composition of two functions like this. I think we just need to be able to find the function itself. So let's find one more function, f of f, and I'll leave you to find g of g. Well, f of f, again, it's an assembly line. First you do f, and then you hand off that answer to f. Okay? So out of the function f is just the square root function. So you get out a square root, but then you go and you plug that answer into f. Well, what does f do to things? It takes the square root, whatever you give it. So that's our weird function, the square root of the square root of x. And really the only restriction here for our domain is that x has to be greater than or equal to 0. And you can see that from that picture. Right. Awesome. Thank you. And so, cool. Again, don't freak out if all that domain stuff didn't make sense. We just need to be able to find these functions, f of g, find this function g of f, find this function f of f, those sort of things, okay? But the domain is pretty interesting. So let's do two more examples. So the composition of three functions. What if I had f of g of h? So again, you're going to take an input x, you're you're going to hand it to the first function. Remember, we work inside out on our assembly line. So first you hand it off to h, and it will pop out h of x. Well, then who's it give to next? Yes, it gives that to g, so it's going to take h of x and plug that answer into g, so you're going to get g of h of x, right? And then the last function to get used is f. So I'm going to come in here with my green, and I'm going to apply f to this output. So it's going to be f of g of h of x. That's what that is. It's f of g of h, where first you plug into h, then g, then f. So let's do it in that order. So first you plug into g, and this is what it would give you. So f of g of h of x would be, first you plug into h and you get out x plus 3. Well, then you're going to plug it into g, and then you're going to take that answer and plug it into f. Well, what does g do to things? G takes anything you give it and raises it to the 10th. So it takes what we give it, x plus 3, and it raises it to the 10th. But remember, that is our output that now gets handed to the function f. But what does f do to things? Well, we look up here, and it looks like f, whatever you give it, it takes it and divides by that plus 1. So it takes what you give it. So here, if you give it x plus 3 to the 10th, it's going to take that and divide by that same thing plus 1, right? So that is our function f of g of h. Cool. Now, recognizing composition of functions. So if we recognize a composition of functions, let's say I have this function. One way to look at it is as a process. And you want to start from the inside out. Well, if you want to think about this function, first you took an x. What was the first thing you did to it on the inside? I guess you added x plus 9. That was your first function to get here, right? And then you took that input and you did a fourth root, right? So first you did stuff plus 9, and then you did the fourth root of stuff to get the fourth root of x plus 9. So it seems like our two functions, if first you do g, then that means that g must be x plus 9, because that was the first thing I did. And then the second thing you did was to take the fourth root. Well, that means my second function right here, f, is going to be the fourth root of whatever I give you. Okay? So there's our two functions. So we're taking this function and viewing it as a process, where first you take x and plug it into the first function to get x plus 9, and then you plug it into the fourth root and you get the fourth root of x plus 9. So it's a way of viewing one function as a process of two functions. Cool. So you can imagine there's a lot of reasons that we would use this sort of stuff. Maybe something like a process, again, just any sort of assembly line, where first you give it to one thing, it does some work, then it does another. We'll look at some really cool applications.